about 10 years ago, through a strange course of events, I got involved with Seafair, and then the UL guys, I got to know them. And, you know, before that, I didn't know anything about putting radios on boats, and I had a lot of curiosity about it. And so with the UL group and some other teams, I had an opportunity to learn quite a bit about how you would put radios in the boats. Now, one thing I know that I've learned from working with a few teams is that you know boats and you know racing. And radios isn't really something you do. And that's okay, because it's fun to watch you race, and I didn't want to see you stop and play with your radio. Today what I'd like to do is talk about really a couple of things. What is a basic radio system? And how would you adapt a basic radio system to the environment that you're working in? I know that in some of the classes, the use of radio is mandatory, and in other classes it's not. Most of the teams that I had experience with were the traditional hydroplane hulls. Those are the ones that I've had experience with. And they present some very unique challenges to using radio. Two of them that are the most distinct are that electrically, a boat, when it's racing, is very noisy electrically. Like if you were to put a nice stereo system in it, it would sound like crap, right? And you're not going to do anything about that. You're not going to put resistor plugs or any of that stuff that filters noise, because that's not the point. So that's one of the issues that we look at when we put radio in the boat, is how do we do it in a way that it works and it's not susceptible to the noise. The other issue is one of the most important aspects of a radio system, believe it or not, we're going to have a few slides where we cover this, is the antenna system. The antenna system is going to make or break. That's the one common thread that I've seen with every team that's called me and said, hey, can you come over? And I go look at it. In every case, the issue that they were facing, the reason they couldn't hear, in some cases, as soon as they pulled away from the dock, or in other cases, they get halfway out on the course, and they lose communications. In every case, it was the antenna system or some piece of that. So we'll talk about that. So a basic radio system really is quite simple. You know, it's going to be a radio system is more than one radio. You know, if you have one radio, who are you going to talk to? And generally speaking, what I've seen as little as 2 radios that a team has. You've got the one in the boat and the one on the shore. And in some cases, they might have a few of them on the shore. So your radio, your antenna system, and whatever headset, earpiece type of arrangement you're using. One of the most important factors when you're putting together your system is that all of these pieces are designed to work together. So that headset up there, honestly, I think I probably got a David Clark headset picture. That's a bad thing right away, because if anybody here knows anything about airplanes, you see those headsets, they look very much like what you want when you're on the shore, right? You want that big earpiece, or the earmuff, to cover the noise. But a headset that's made to work in an airplane is not going to work with these radios. They're just completely different. Electrically, the way they're set up is different. Also, even your antenna system. I've actually been over to visit somebody who had an antenna for one frequency range of a radio, and the radios were a completely different frequency range. So one of the most important factors when you put together a radio system is that you have compatibility all the way through. Now, I know a lot of radio dealers around the country. I spent 5 years working for ICOM. I won't hide it. I'm a big ICOM fan. Honestly, I don't see a lot of ICOM radios in the racing. They don't have the presence. But what I mean by that is dealers that sell those brands of radios haven't decided to go out and find the accessories that plug in and are compatible. So it doesn't really matter what brand of radio you use. I'm brand loyal to those guys, but there's other brands that are very good. Quite frankly, in the radio business, you're going to see other brands. I see a lot of Motorola CP150s and CP200s. I see a lot of Kenwoods. I see a lot of these black box radios. You'll see those at a lower price point. obviously, if you beat them up. And honestly, this environment's kind of brutal to stuff like that. But whatever you get, and however you buy it, if I could make any one recommendation, it would be to find somebody who sells these as a package. I think SRP does, right? Yes, and I've spoken to them a few times. I have no connection with them. I want to be very clear on this. But if you're going to buy radios, the best thing you can do, you might think you're spending a little bit more money, but I've been with people who bought this component and bought that and found out this isn't going to work with that, and now they're spending more money. So the best thing you can do is go find somebody that actually builds packages for what you do. And there's a couple of companies out there that do it, and SRP is one. Now, one of the things that's really important when you choose a package, and this is assuming that you haven't already bought your radios, okay? If you're putting together a new package, you're in an ideal position to make some good decisions or bad decisions. One of the things that's really important to know is there's two basic frequency ranges where these radios are going to be available. You can get VHF radios that are down in the 150 to 174 megahertz range. You can get UHF radios that generally are in the 450 to 470 megahertz range. Those numbers don't mean a lot to you, except that as we start to look at things like the antenna system, they mean a lot. And as we look at interference, they mean a lot. So let's go. We're going to jump first to an antenna system. And what is a basic antenna system? So it's really a system. It's not just an antenna itself. The antenna element really is at the bottom. The feed line or coax. So on your handheld side, on the shore, you're going to have a radio with an antenna already on it, right? But when you go into the boat, it's a whole different story. I have seen people who put radios in little pockets, and they had a little rubber ducky whip on them. It didn't work so good. You know, in theory, RF goes through fiberglass. You know more about what you build your boats out of than I do. All I know is that a couple of guys that I worked with that did that, as soon as they get out, it didn't work. Once we put the antenna outside, and you'll see it. You'll see a couple of them. There's one right up here. It's not the type I prefer, but this little shark fin right there, that's their antenna. As soon as you move an antenna outside, now everything changes. In order to do that, though, what you need underneath of it is a ground plane. And what the ground plane does is it provides a launching point for the RF. So, and this is in very simple terms, but in simple terms, when you start to put RF out of an antenna, if it has a solid ground plane, that's a reference. And the RF goes out the way the antenna was designed. It goes out, and we'll look at some patterns here in a minute. If you don't have a ground plane, two things happen. RF starts to go both directions, which means that it's not traveling as far. And then you get what's called a mismatch. That can damage your radio and things like that. So when we look at the VHF band and the UHF band, there's a couple distinct differences. VHF has a radio horizon, meaning if you're on the water, it'll go 25 miles before the earth curves and drops off and you lose range. But a quarter wave element, meaning and a quarter wave is a typical basic cheap antenna, is 18 inches tall. And that you get into a couple issues there. Where you really get into an issue is the ground plane, because the ground plane is proportional to your element. So to make an ideal ground plane, meaning the piece of metal, either a disc, it's a 36-inch radius, right? That's, I worked late last night, that's what, 72 inches?
6 feet, yeah.
Yeah. Where are you going to do that on the boat? You can do a plus, a cross pattern, okay? But you're still doing 18 inches each direction, 4 waves. Truthfully, you could get away with 3. The most important part, though, is that VHF, just because of the nature of it, I was looking through some emails. I wrote to some dealers before I put one of these together a few years ago. I was looking at their emails. It was fascinating. These are guys that do radio 50 years. And they wrote some long dissertations. And it was funny because some of them really got into why is VHF so susceptible to noise? And it was really interesting the different theories they have. I don't actually care why it is. If we go into a building that has a lot of computers a lot of fluorescent lights, or some of these big electronic ballasts, you start getting a lot of noise and scratch on these radios. You put them next to one of those motors running, and whatever you do, you're going to get noise. I've seen it at UHF, and we'll talk about how you prevent it, but it happens. So let's go to UHF. Now look at UHF. A quarter wave element all of a sudden drops down to a 5 1/4 inch width and a 10-inch radius. And truthfully, you can get down 6 inches. So now all of a sudden you can build an ideal or a near ideal antenna system in a way that you could put it on one of your boats. One of the things that I've seen people do most often, and it's very successful, is to use the little round antenna, and I had some pictures of them, and just put them on a hatch cover. And they take an aluminum plate and put them on a hatch cover, and that's enough of a ground plane. When we do that, the other thing is you'll see is UHF just is not as susceptible to the noise. You will get it if you don't place your antenna properly. I worked with a fellow who had a couple of classes. I think he was a national mod and something else. And he started, the engine was in the back, and he started by putting it on a hatch that was right next to the engine. And I asked him, after he took it out a couple of times, he said, "I'm getting a lot of noise." I said, "I would have expected that." We talked about it, but it's kind of where he wanted it at first. And so what he did is he moved it to a forward hatch cover. He said, "It works great." So, and he was one of those folks that was using the whip on the antenna in a little pocket in the capsule, right? So he was trying to get RF. Originally, his original installation when I met him was a handheld radio with the stock rubber duck antenna inside the capsule, and he couldn't get very far at all. So we talked a little about ground planes. Ground planes are really critical. It's what's going to make or break the whole thing. So ideally, it's going to be flat, round, and directly underneath the antenna and center. It doesn't have to be round. When you get down to UHF, it's very forgiving because now all of a sudden, if you move a couple of inches, that's a smaller percentage. When you do your mount, the braid side of the antenna mount needs to be well bonded. It needs to be connected to that ground plane. I've seen people do copper, just copper, the flat copper stripping inside the roof of the capsule, and then they bond it to that. A poor ground plane is going to affect your pattern. We're going to look at some patterns. Really important. When we talk about the ground plane of an antenna system, this is an RF ground. It's not an electrical ground. Don't connect it to your engine block or anything electrical. Just it floats right underneath of the antenna. Its only electrical connection is to the braid side of the coax, right where it meets the antenna. That's it. When you look at antenna patterns, this is something that gets to be really important. When you're out on the water, as you move and go different directions, is the pattern of your antenna omnidirectional, like the one on the left. So the antenna is centered right in the middle. If you're looking down from the sky, is it going in all directions? Or do you have side lobes, right? Now think about that. With the side lobes, if you're going a certain direction and the person that you want to talk to is on the right or the left, it's going to work okay. But when you turn, and you're a mile out, maybe, and the person you're trying to talk to is directly in front of you or behind you, that's called a null. And that's where you're not going to have as much energy going to them. And that is going to have some effect. A true omnidirectional is something that you're going to get off of like a whip antenna or one of the little round, you'll see in the little round stubbies. And this is what we shoot for. This is what we want. Yeah, those antennas exhibit lobes and nulls. They work. You know what? If you look at the limiteds, they all seem to use them. Honestly, I think they look good, and that's why. Then there's another issue that we'll talk about in a minute with those antennas. This one here, I've noticed this one here is a little bit different. This has a little element coming off the back And that's going to affect that. That's going to reduce the lobes. So this makes it more of an omnidirectional. But if you get just one of the traditional shark fin types, you see a lot of that. Now, these are the little round, stubby max rads I'm talking about. You'll see these on cop cars. You'll see these on buses. If you start looking around, you're going to see these. I'm going to tell you a couple of reasons why I think these are the best antenna for what you do. Number one, safety. If you go for a cheap, low-cost quarter wave, the mount that this screws onto is called an NMO mount. Okay, if you're taking notes, NMO is an industry standard. They're dirt cheap. You can go to hamradio.com and buy them for like $12. You punch a 3/4 inch hole and they mount right in it. And if you punched a 3/4 inch hole in an aluminum plate, you just made your ground plane connection. It's beautiful. You got to watch the thickness. That's the only thing you got to watch. They have two thicknesses. A standard NMO is made to go in the body of a car or a truck, which is fairly thin these days. They have an NMO-THK thick, and that'll go up to a 1/2 inch thick. So now you have some tolerance. This antenna is going to be a good $40 or $50. So some people say, well, gosh, I can buy this little quarter wave for $10 and cut it to my frequency. There's a couple of problems with that. You have a wire whip sticking up out of your boat, and you've got people working around it. And believe it or not, I've been a ham radio operator now for over 20 years. We have had multiple people, multiple hams in the U.S. have died from having an antenna stuck up their nose. I'm not kidding. And if you've got people working around your boat, and you've got a wire sticking up, it's a hard wire, it's a hard spring steel, it can happen. And that's why I think it would be a bad thing to go. I've actually seen a couple of boats that have those little quarter waves in it. Don't do that. Because for 30 or 40 bucks, you can save somebody's life. They had an incident right here in Seattle where a kid was walking down the street in the 90s, and some punk had bent the radio antenna on a car at a 90-degree angle the night before. He was walking along, bent it. The kid walked along, went right up his nose and into his brain. And the way I found out about it is, some radio station made a joke out of it. They were calling him Antenna Boy, and they were calling him on the radio, or on the phone, and putting him on the radio. There's no joke, man. I mean, to get that out and not kill him was amazing. So I'm aware of 2 incidents in the U.S. that were hams, that a radio fell over and they bent down, or an antenna fell over and they bent down, and they jammed right up in it. They were killed instantly. So I prefer these because they're durable and they're safe. And they give you the omni pattern. Now we looked at the top view. The other view that's important when you're looking at your radiation pattern is the side view. And that's right up at the top here. The side's okay to have lobes if they're sticking straight out. If you look up above and you see how they're pointed up at an angle, if you've got one of these blade antennas and a poor ground plane, or the wrong style of blade antenna, then you'll get a pattern pointing up. And what's going to happen is, as you start to go out away from the shore, your RF is literally going over the top of people. Now, when you're within 500 feet, it's not going to matter. But as soon as you get out to the other end of the course, it's going to matter. And so the antenna pattern is really critical.
Graphite composites, like those during the map, does that cause anything?
That's a really good question. And where that causes a problem with the graphite composites is if you're trying to use the antenna inside, right? RF, a lot of antennas are made with a fiberglass. The marine antennas are made with a fiberglass shell around them. True fiberglass, in theory, doesn't affect RF at all. But that's only if it's fiberglass. As soon as you start to get into either carbon or any of that stuff exhibits, it's got stuff that'll mess up your RF. When you put your antenna system together, if you've got a friend or access to somebody who can help you analyze your antenna system, it's really important to make sure that you have what's called a good match. Now, you get your good match a couple of ways. If you know the frequency of the radios that you're already using, when you order your antenna, make sure that that antenna is designed to work within the frequency you're on is within the range of the antenna. If you do a proper antenna mount, you're going to be matched. But you still want to check. SWR, anybody ever play with CB radios? Basically what SWR is how much power goes out versus how much comes back into the radio. Whenever your antenna is not matched, or if you've got bad connectors or anything like that along the way, what happens is the RF goes out the coax, but then it turns around and comes back into your radio. Two things happen. It's not going out where you want it to go, and it's coming back into the radio and heating it up and damaging it. So that's why having a good match is critical. So, again, the person who's got the radio on the shore, you've got a stock factory rubber duck antenna, you don't really have much to worry about. But once you get on the other side, once you put this in your boat, you need to make sure all your coax connectors are solid, meaning that they've been crimped properly or soldered. Find somebody that can do that. You want the minimum number of adapters. Now you're going to have adapters. We talk about adapters because this is another area where you want compatibility. So let's say you have Motorola CP200 radios. If you unscrew the antenna and look down inside with the light, you see there's a very fancy connector with a really tiny pin in it. And there's an adapter, it probably costs 30 or 40 bucks, I think, that screws down, is designed to work with that radio. There's also a lot of other adapters that look similar, but they're not designed to make. They're for other radios. And I had a fellow, actually a real popular driver, called me for one of his little 2.5 liters. And he said, this radio just doesn't work. And I looked inside, and they had the wrong adapter. The adapter screwed down inside and damaged that connector. The problem with that is now you've got a $200 radio that needs a $200 repair. I think in the insurance business they call that a total loss. So your adapters, and the reason you'll need an adapter is you have a handheld radio. They ship it with the little rubber duck whip antenna. You're trying to go to a different type of antenna. Every manufacturer has adapters available. Make sure that when you buy it, you buy an adapter for the model of radio, the make and the model that you have. I've seen Motorola's changed the connector a couple of times, not very often. Kenwood's done the same thing. They'll look the same. You'll have one that's made to work with a Kenwood radio. You screw it in that, and it'll screw right in because the thread's the same. But if you screw it inside that Motorola, you damage it and it won't work. You want to make sure that the antenna is for the right frequency where you're at. Again, I went out to a fellow who had a UL, and he said it's not working. And we looked at it. He had UHF radios and VHF antenna. And it happens. You end up with a boat, and you buy some radios, the boat already had an antenna on it. It happens. And a proper ground plane. And then the headsets. The headsets, the wiring harness, and the antenna adapter are really the three accessories that you need to ensure compatibility with the models of radios you have. So let's look at some troubleshooting. First thing, of course, is to make sure you have power. Generally speaking, what I've seen is you're using the batteries. And so that's a pretty simple deal. With the headsets, particularly the wiring harnesses, one of the things I've seen, a common failure that I've seen, is they'll say when I plug in my harness, the radio transmits continuously. I've probably seen that about a half a dozen times. And what that is in every case is their harness has become corroded internally. And there's a short in there and it's causing the radio to transmit. I had a guy bring his harness by and I said, well, I'll look at it, but I don't think I can fix it. And you can't. If that happens, the best thing you can do is go buy a new harness. The reason is the wire that they use in those is actually, I don't know if you've ever played with this stuff, but the old headphone cords from the 70s, if you went in and tried to strip the wire, it was this really fine foil wrapped around a cloth, if you've ever seen that. That's what they use in these harnesses, and that's actually a good thing because it's most durable for flexing and bending and all of that. The best suggestion I have, and it's kind of a pain in the neck to be honest with you, is to not permanently install it in your boat. If you're going to be out for a weekend, strap it in, and you're done. Dry it. Either dry out your capsule really well, if that's possible, I don't know, or just pull it out and put it in a dry environment, because it's the moisture that really gets you. Now, one of the biggest problems is moisture while it's got electrical energy on it. So if you leave it plugged into a radio, corrosion happens much faster when you have water hitting a wire that has even the slightest amount of current running through it. You'll get corrosion pretty fast. So really, I know it's hard because what you guys do, I've watched, and it's fascinating. You guys go balls to the wall, really, and things get beat up and you do things fast. But the best care that you can take of this gear is what's going to protect you, keeping it dry. The RF, do you have any indication that it's transmitting? There's two ways to know. You're going to get a light on the radio most of the time. It's going to give a light. All that means is the radio thinks it's transmitting. Okay, so if you see the little red light or the little indicator on the LCD display, it thinks it's transmitting. But that doesn't necessarily mean there's power coming out. There's a lot of scanners out there these days. If somebody's got a scanner, you know your frequency. It would be good for you to know your frequency. Write it down somewhere. Try it. Try it two ways. Right up close first. Get that scanner, get that radio right up close. When you key up, you hear something coming out of the scanner. And then go at a little bit of a distance and do it again. Because that's going to tell you how much RF power is coming out. A real common complaint I've heard is when I'm at the dock, I do a radio check, it works great. As soon as we go out and stuff. That's usually an indication that there's a pin broken somewhere in your antenna system. Those adapters, you know, what is going to happen is you're going to have an adapter screwed into the radio and you're going to have a connector coming off of the coax onto the top of it. I've seen the connector, the pin in the coax connector broken, and that was what the problem was. The next thing, though, when you're troubleshooting, let's say you have that scanner or another radio frequency, you key up, do you hear audio? That's the next one. If you get at a distance and you can hear the noise, the carrier when they key up, but you don't hear audio, you've got RF power coming out of your radio. The issue is more of an audio connection, your harness, your headset, something like that, is where you have a problem. And that's where you'll check your PTT function, one or both ways, that type of thing. That's what I have prepared. Are any other questions?
Just more of a comment, information thing that I found with radios. Most of the guys who are renting radios in the boat, the drivers, are wearing the little foam earbuds that we sell, and they're not cheap. They're $100 to buy a set of those. And when somebody comes in to get them, and they go, "Oh, I've got a bad set of headphones. Sell me another one of those." And there's usually a bit of sticker shock when they ring them up, and they don't understand the question that I get is why do these dumb little things cost $100 when I can go to Fred Meyer and buy iPhone skull candy earplugs for $25? Well, those are stereo and they don't work in the mono radios. These radios are mono, and that makes a difference too. So
it's also what they're made of. They're different and they're more durable than what you're going to get.
Yeah. But I get that a lot.
Talk about ground plane. Talk about minimum size. Can you have a ground plane that's too big?
No, you can never have too big of a ground plane. Yeah, I've got a 15-passenger Chevy Express van, which is good for radio, because no matter what frequency range I'm on, I've got ground plane. You can never be too big. You can only be too small. That's a good place.
Yeah, I just wanted to say something about the value of those standing wave ratio meters. We have UHF in my boat. We've got all the right stuff. We've got the right ground plane. Everything's great. And yet we had terrible radio communications. And finally we got a meter, and we checked, and we were getting, I think it was almost as much power back as we're getting now. It was like 4 to 1 or something like that. It was terrible. I think a good ratio, you said 1 to 1, that's theoretical. 1.25 to 1 is considered very good. If you have several cables connected together, even up to 1.5 is not bad. But 4 is terrible. Well, we found out that we had a dirty connection right at the antenna. We cleaned that. Everything was perfect after that. But we were still having a problem. It would work great at the dock, and it didn't work when it got away. I found the problem was that with my headset, I take the radio and I clip it on my belt, right next to my cell phone. I now leave my cell phone in the radio box when I go up on the tower, and it cured a lot of problems. So.
As far as SWR, under 2 to 1 is what you're looking for. Under 2 to 1, 1.5 to 1 or lower. Yeah, 1 to 1 is theoretical. And that's what we get on the bench. You will see attenuation by having a radio next to your body. Okay, that's something that happens. It doesn't affect you. That's another benefit of using UHF over VHF. The VHF will be attenuated. There's also a safety issue, in the sense that our bodies are resonant up to 300 megahertz, 30 to 300 megahertz. So VHF is actually considered harmful to the human body. At the power level that a handheld radio is considered safe. I mean, all of the minds that look at this consider it safe. Where you get into issues is the 25-watt radio on your boat and on your pleasure craft is where you get into some issues. And that's where they say you want to keep that 10, 15 feet away from people. I don't know how you do that with something. But there's some really good comments there, like cleaning the antenna, connector, that type of thing. And again, on the connector itself, where it touches the radio, I've fixed at least a half a dozen connectors where the center pin was broken. And that's what carries that RF through. It gets you the same thing. Anything else? Okay.
Bob brought up carbon fiber, and earlier you talked about how UHF radio needs to be separate from any electrical system. Does the carbon fiber have conductivity? Because we found when our ground plane was right against the carbon fiber, we got all sorts of issues we had to insulate.
That could be an issue. That could be an issue. It's part of the problem there, though, and this is where you're going to end up having to do some experimenting, maybe, is it's not, with RF, it's not a physical electrical connection. If you're trying to make a light work on your car, you need to make it the metal touch, right? And if you put a piece of plastic in there, it insulates it, right? Black tape insulates it. RF couples inductive, so it couples it, and if you put the ground plane on top and put a film between it, that doesn't necessarily insulate. The solution that I've seen work the most is the hatch covers. That's what I've seen work the most. At first I thought, I don't know, we'll see, right? I wasn't sure about that. And guess what? It's the solution that I've seen work more often than anything else, because it's kind of floating in between. And so that seems to have worked better. It's also at the same plane, and then that helps. But when you put it on top of carbon fiber, you can put an insulating material in there that may or may not help, because you've got the inductive coupling.
Now, one other comment about power on the radios. Again, I've got UHF radios, so they're not as noisy. However, we ran our power from our battery up to all the instruments. We used a twisted shielded pair, so that we're not picking up off all the other stuff. And then also from the instrument panel to the radio itself, we converted our radio so that we're on battery power. That way we don't have to keep taking it out and charging it and everything. And that line also is a twisted shielded pair, and that helps a lot.
So there's two things you can do. The twisted shielded pair is a good solution. Another solution is the ferrite beads, or the cores. You'll see them, in fact, you see them now on computers and stuff. You get a computer cable, it's got a big round thing on it. That's a ferrite core that the wire's going through. What you do there, you can get these at Radio Shack. You take your wire and you loop it 3 times, 2 or 3 times around that. And that acts as a choke, and it stops a lot of different kinds of noise. It'll also keep RF from getting back into your stuff. If you're getting RF back in theory, with a good antenna system, you're not running a lot of power. 5 watts is not a lot of power. That's what most handhelds put out. But if you ever felt you were getting RF back into any of your wiring, if you take the ferrite cores and you need a little extra length on your wire, you wrap a couple of 3 times and then pass it through. at each end. You don't do it in the middle, you do it at each end of a wire. That will also choke it.
I don't know if it's a type of equipment to have it. For me, that I see, you're sitting in the boat, and you're strapped in, you're at the dock, it's quiet, you're talking to your crew, volume's perfect, and then you fire the motor, and you go out, and it's noisy, and you can't hear. And if you've got your mom strapped on and you look to the race boat, you can't always look down and see the mom turn. Is there a way you can set up where you've got two volumes and you toggle from left to right from a low volume to a high volume?
I haven't seen that. It's a good idea.
We have done that in our boat. What we've done is we have a little rheostat up on the dash, and we turn the radio volume. We keep our radio in a little Pelican box, so it's completely sealed in case you go upside down. And we've run the output to the earphones through this rheostat. We turn the radio all the way up, so that when Greg's sitting at the dock, he can turn it down and not blast himself out. But as soon as he fires up the motor, he turns it back up, so there's no resistance. And it works great.
That's brilliant. That's brilliant.
And my crew chief will tell any of you guys how to do it, because we both work in wiring, so he came up with it. It works great.
Back to carbon fiber, is there for your antennas or anything like that? Is there any insulators or anything you should do between your connections of mounting your antenna or your plate that might touch or go into carbon fiber? Because a lot of boats are being built in carbon fiber where the whole boat is pieces of carbon fiber which is attached then to the motor and then to this, which is that. Then it also becomes a ground. So is there some way to protect your antenna and your connections?
So that's where you're really going to get into experimenting. And the first thing is build it, use it, and are you having problems? The problems you're going to see that you're going to see is one into the other. You're going to start hearing noise. You've heard it before, the electrical noise that's consistent with the speed of your motor. That's the most common noise you'll hear. If you start hearing that, then that's where you start looking at the solutions, and there's multiple. One of them would be placement. One fellow that I worked with, it was like the National Mod back there, and he had it back on the back, right by the exhaust. And so the antenna was physically right close, plus the coax was running alongside of it. We don't know what it was. We don't know if it was the antenna being there or the coax running alongside of it, because coax can have some noise come in if it's heavy. But by taking and moving the entire thing up to the front, to a plate where a hatch cover where the wing is, it took the problem away. Let's say you did that, you still have a problem. Now you'd be looking at what can you do to insulate that plate. And honestly, you're going to know your boat better than I am. And whatever you can do to insulate it. I guess what my question would be is this something you're starting to see? Is this a problem you're starting to see with these carbon fiber boats?
We put the antenna for a race pack actually all the way up on the tip of the sponson, but then typically the antennas that all the unlimited use, and more so the top of this part, filled with the shark fin, and everybody thinks it's aerodynamically better or something like that. The round one looks just as aerodynamic.
I had somebody call BS on that. So he was, I don't know, I guess that's where you would get a wind tunnel. I know, I just bought a Chevy Bolt and I was reading the book about it, and they were looking at the aerodynamics of that, and it was fascinating to see that if they shaved a 32nd of an inch, it had a huge impact. So, I don't know. That's a good point.
Just one last comment on radio. The technology is great, and once you get the good connection, then you need to talk with your radio guy and get a vocabulary set up. Because when you're out there and the guy is at the radio yelling, no, 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 or go, 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 you can't tell what he's saying. So you have to really decide the vocabulary you're going to use for the situation. Because no matter how good you communicate, unless the words coming across are making sense.
David brings up a really good point that I haven't even touched on. We talked about these technical aspects of radio, but when you look at the practical use of radio, that's a whole different thing. Everybody's got a cell phone today. And you're talking to somebody on a cell phone, and they say something, and you know where they're going, and you jump right in there and say that or whatever. You can't do that with two-way radio. Two-way radio is really two one-way connections, right? So whoever's holding down the push-to-talk is talking, and you can listen to them. If they're still holding that push-to-talk button down, then they're not going to hear you when you go back and try to do that. So keeping your communications short and brief, knowing that you need to, if you start rambling, there's the person at the other end. What you're doing is happening at a very fast pace, very, very fast clip. So keeping your transmission short and a little pause to make sure that you're not jumping on somebody. Another thing that's really important is the time from when you hit the push to talk to when the actual link is established. And there's a time there. And sometimes it's a third of a second. We look at it in 100 milliseconds, 300 milliseconds, 500 milliseconds. It's stuff we look at. When I was doing radio support, it was a big issue because the common user doesn't think about it. So they hit push to talk. They start talking. If you've got a 500 millisecond setup time, a half a second, how many syllables are just lost, right? If you start talking before you hit it or as you hit it. So hitting the push to talk and then pausing for a second, it's hard to do. But it's going to make those communications. And then the words, right? No and go, that kind of a thing.
Yeah, you've been very good in the past coming out to shops and helping people with radios. I assume if they call you, you're still available for that?
I am a little bit. I have a wife. And a wife. And usually she prefers that I work on her side. So, if she goes out of town, it's a lot easier. She hasn't been traveling as much lately.
Boat racers, we have wives too, but they let us play with boats.
She lets me play with a lot of stuff, and it's just how far do I push it. I'm always willing to give some input and help out. There's not a lot of money to be made. I gotta be honest with you, people. It's not. So if we do it, it's gentleman's type stuff, and I'm always willing to help people as much as I can. But it's not what I do for them. So, but yes, Howard and Jan know how to get a hold of me. I'm on Facebook. I'm friends with quite a few of you folks on Facebook. You can find me through one of them. If you want to take an email address down, I can give it to you. My ham call sign is in like Nick 7QOR at yahoo.com.
Drink scotch or beer?
Yeah. Well, I can't for the next 2 weeks on that call, but yeah. I worked all night. Okay, thank you very much.
Next up, we have Patrick Gleason to talk about safety gear.